So what I've shown you today is these various packages. I've shown you a few of the packages in the Tidyverse, unified by these 4 principles that you want to solve complex problems by breaking them down into simple pieces. My goal is to dig a pit of success that you kind of fall into accidentally. It's still it's still, not that close. It's still not that easy to fall into the pit of success with R, but that's something that I am trying to work towards. It's really important to remember that it's not data science is done by data scientists who are humans, and a really important part of recognizing that there's humans involved is thinking about the importance of communication, not just through prose, but also through writing code that is easy to understand. If you'd like to learn more about the Tidyverse, there are 2 places to start. The first is tidyverse.org, which is kind of the home to all things Tidyverse. And then the second is this book, R for Data Science, which I wrote with Garrett Grohlman. That is available for free online. And if you love dead trees, you can also buy it as a printed book. Thank you.
We've got some time set aside for questions, so we're going to open the floor to questions from the audience. Wow, you must have thought of everything they ever would have done with others.
What do you think is like the biggest outstanding challenge for the art community broadly?
That is a difficult question. I think, I don't know, like the things that kind of challenge me to some extent are the things that I kind of spend less time thinking about, because I generally, like, what I do is build tools, but the things I think are really important are to some extent the stuff that's like outside this diagram. Like, where do the questions come from? Like, how do you come up with a good question to ask of your data set? Or how do you say, well, actually, this data is not the right data I need to answer my question? And how do you know, like, to say, hey, this is not, I need to go back and collect more or different data? Like, similarly, I've kind of like skipped the communication piece so I could fit in these URLs, but like, that's also really important. Like, how do you know when your data analysis is done, and then how do you most effectively communicate that to other people? Like, technology is just a relatively small part of that. So I think, like, those are the sort of things that I think that are the biggest open questions to me. Like, there's lots of stuff around, reproducibility is really important, and there's this reproducibility crisis in science, and even there, like, there's some kind of technological component to the solution, but there's also this, this remembering that we've got humans in the loop and thinking about incentives, and those are kind of the open problems that I think about more, things that I don't think about.
Do you have a favorite part of the process, whether it be exploring the data, communicating about it, figuring out a good question?
I don't know. I mean, visualization is where I got started, and that's still, I really enjoy getting to that part. It's just so sort of tremendously rewarding to, like, there's often like a lot of frustration in the early parts, but it like pays off when you start creating like really cool looking plots that actually help you understand what's going on. And then that's the way when I teach data science, I start with visualization because it's this immediate payoff. It gives you that kind of motivation to push through like the painful parts about learning programming. Like that's what I love.
Other questions?
Go on.
Yeah, I'm just kind of curious where you sort of fall on, this is more philosophical, like some schools of thought on visualization is very minimalist, like the data to ink ratio and stuff like that, and others emphasize like being more redundant, So I was just curious what you think is most effective.
Yeah, I mean, this is sort of like the most minimal plot you can possibly create, right? There's nothing on this apart from the data. And I think that kind of works well here because the context is so obvious and so familiar. But by and large, I think you're almost always better off, like grid lines, good access labels, they help you interpret the data. They help people who are not so familiar with it interpret it. I think Tufte, who kind of coined the data-ink ratio, he tends to give advice about, his advice is best thought of as how do I create beautiful plots, not necessarily how do I create maximally effective plots. There's also like some trade-off, like creating a plot like this is just like 5 minutes of slinging together basic ggplot2 stuff. Creating a plot like this, you know, that's like an hour of carefully thinking about the aesthetics and tweaking, well, exactly how wide should that line be, and should I add a little bit of transparency, and what exactly is that shade of brown that matches my slides, and you know, that's important for kind of high stakes visualizations, but for most of the stuff you do every day, it's not worth spending the time polishing that.
Could you talk a little bit about your GitHub and how like what sorts of resources we can use, like through your repository?
Yeah, so that's a really, so I think the other thing that we didn't really touch upon, but that is like really important to my work, and I think really important to learn if you want to be a data scientist, and that is learning a tool like Git and GitHub. And so I think this is why the Tidyverse has been so successful, because it's not just me, that there's a whole community of people contributing to it. And that is one of the things like that I'm trying to do a better job of, is like saying if you find something wrong with a Tidyverse, what do you do? And so now on tidyverse.org, we've got a contribute page. If you've found it useful and you want to give back, this is the place to start. Even if you are a relatively new R user, you can start kind of contributing very, very easily because you can help other people. You might not be able to help answer other people's questions, but you can almost certainly help them frame them better in a way that's more likely that someone else can answer. Or maybe you discover some weird behavior in the Tidyverse and you want to contribute some documentation. And so I think that like sort of explicitly recognizing that this is a community effort and that, you know, all of you can contribute to this community is really, really valuable. This is also the place, you know, if you want to live on the bleeding edge and try out all of the latest and greatest development features, you can also install packages from GitHub. Sometimes that's a great idea, and sometimes that ends in tears.
Is there another question in the back?
This kind of answered it. I was going to ask, just for data science tools in general, what is the best way to keep up with the cutting edge for maybe people who are kind of data scientists by default? We want to spend most of our time exploring the scientific questions we're interested in and just keep apprised of the tools that we need to do that.
Yeah, I don't kind of know the specifics, but I think the general idea is you want to make sure you've got some kind of feed of new ideas where you just kind of skim that every now and then. So that might be a mailing list. Personally, I use Twitter a lot. I use like a feed reader and read a bunch of blogs. Specifically for the R community, I think R Weekly is a really good resource. So they kind of, every week they do a little newsletter about a bunch of things going on in the R community. And so this is something I think like you need some balance between like doing your job and learning better ways to do your job. Because if all you do is learn better ways to do your job, you never get anything done. So I think just like having, you know, saying I'm going to budget like 30 minutes a week or an hour a week, I think is a really good idea. Just read our weekly. You know, maybe you see something that's immediately applicable, you can try it out. But that kind of integrating kind of continuous improvement into your own practice, I think is really valuable.
So you talked a lot about visualization, and R has always been very strong at kind of static visualization until very recently. Interactive visualization has only been more recent in R, while other traditions have had it for a longer time. How do you see the future of interactive visualization in R?
Yeah, so I have kind of my own entry into that canon, which is GGVis, which I don't even remember where it lives or how it's spelled, which tells you how much I've been thinking about it lately. So this is a package. This is kind of designed to be like the next iteration of ggplot2, thinking about an interactive grammar of graphics. So this is like, you know, it's a package, it works. It's currently laying fallow just because I don't see, like when I kind of look broadly at the things that people are, that challenge people in R, like visualization is not one of them, partly because there are some other great tools out there like like the Plotly and the Plotly, which allows you to take ggplot code, very similar to ggplot code, and create interactive graphics from it. So that, like, from kind of an intellectual perspective, like ggplotly is not very satisfying to me because it doesn't sort of break down all of the types of interaction into a grammar and think about how they can be recombined. But like practically, it's really great and it's easy to use. The other tool that's not exactly interactive visualization, but kind of plays in the same place is Shiny, which is a tool for making web applications in R, and that allows you to very, very quickly write a little bit of R code and get an interactive web application out of that. That again, that's something that allows you to move from, you know, we're writing a report where you both pose and answer all the questions to something that's a little bit more interactive and the user can ask their own questions. I think learning stuff like that is really valuable. That's another thing, like learning a little bit about Shiny like makes you look so good because people think making web apps is really, really hard, and you can create something with Shiny in a couple of hours that looks really impressive.
Whose idea was it to put the terminal in our studio? Because it's like the greatest thing that's happened in my life in the last 2 weeks.
I do not know, to be honest. So there's a few. So the other thing, like that people, there's like a whole bunch of new features in the latest RStudio. The other thing that I have I'm like, ugh, whatever, that people love is you can now like, if I remember how to do this. You can now like, that's not the theme I was looking for. Maybe I'm not running the most latest version, but you can now have like a dark version of RStudio where everything is black. And like, people love that. Yeah, but the terminal, so the terminal, and again, I've like forgotten the keyboard shortcut, but that's terminate, not terminal. I think it's, maybe I haven't updated my RStudio for a while, but there's a cool terminal, and you can do, tools, terminal. And you can do the thing that you've always been wanting to do. I don't even know. You can like run Emacs in an RStudio terminal if you want to. And now, of course, like I won't be able to exit Emacs, so I'll just kill that terminal.
You might elaborate on the communication piece to the process. You mentioned it being a really important part, and I'm just wondering in terms of having effective visuals to communicate to people that don't really understand your data, what are some of the tips that you can offer for that?
Yeah, so this is one thing I don't really talk about much in R for data science, but there are some pointers to good resources. So this is just R for data science, the book, and then I think, that is not where I put the links. But there's a few resources. So Alberto Cairo, who's a data journalist, has a really nice book on kind of writing, like how do you create graphics that communicate to people really well. And there's a bunch of good books. Stephen Few has some, but I kind of like Alberto Cairo's sort of mix of sort of practice and theory. But that's just a really, really hard problem. But certainly there's good resources, but it's kind of like a lifelong journey of learning how to do that effectively.
Other questions?
What sort of problems do you see yourself working on in the future as you sort of fill out the Tidyverse and ecosystem?
So one of the things that I've been thinking about kind of more recently is a little bit more about kind of process and workflow. So there's sort of three kind of questions that I've been thinking about. So first of all, like, if you want to distribute your code, if you want to distribute your reusable functions to someone else, you put them in an R package. What should the equivalent be if you want to distribute an analysis? And there's a lot of similarities between a package and analysis, but there's also some major differences. I'm also kind of interested in this problem where you work on a project, you get a great, you're working on a paper, you make a beautiful plot for it, you submit the paper, like 6 months later, or 9 months or a year later, you get the revisions back, and then you go to recreate that plot, and then all of the packages have changed and your code no longer works. So there are some good tools for kind of fixing that problem prospectively. Like if you decide, I want to make this analysis reproducible, you can kind of, if you do that from the get-go, you'll be okay. But I'm also sort of interested in like, how can we make this like just work in RStudio? How can we have a system that's kind of turned on by default so you can always roll your package versions back to a known good version even after you've accidentally broken them all? And then finally, the sort of challenge that as your data analysis gets bigger and bigger, often you might have parts of the analysis that are computationally expensive, and you want to, when your inputs change, like when the data you get changes, you want to do the minimal amount of recomputation to update all of the outputs. And that some people use Make for that, which is a very old build system. I think like recommending that our users use Make is kind of cruel and unusual punishment, because Make uses this weird macro language that was written in the 1970s and is never not used anywhere else. I think the thing that's really interesting about that problem is that solving that problem, like thinking about when something changes, when one of my inputs change, what's the minimal amount of code I need to rerun to update my outputs? That is actually exactly the same problem that Shiny tries to solve. Because in Shiny, basically what you do is you just kind of connect the inputs and outputs together, and when the inputs change, Shiny automatically runs the minimal sequence of code to update your outputs. So how can we kind of bring that idea both to like individual R scripts or R Markdown documents, but also to bigger projects? So again, when your inputs change, you can just push a button and redo all the outputs without wasting effort.
Other questions?
Do you think there are any packages that are missing from the Tidyverse, and if so, what would they be?
Yeah, so one, I think the area where there's kind of the biggest hole currently is the sort of the modeling piece. Like, so Broom, what the Broom package does is it takes a model and turns it into a tidy data frame, which allows you to visualize it really easily. And Model R is kind of, it's basically sort of for teaching modeling in R for data science. It's not like a fully fledged modeling system. But recently we hired Max Kuhn, who wrote the Carrot package, which is a very popular machine learning package. And what he's thinking about is like, what should kind of modeling in the Tidyverse look like? So I think part of that is thinking about like explicitly, like how do you, like what is a model, how do you iterate? And then also sort of taking into account the computational environment has changed. Like if you're working with a big data set, you probably don't want to bring all the data into R to fit the model. You want to send the model specification out to wherever the data lives. Like if your data lives in Spark, you want to use Spark's tools to fit the model. But ideally, you want to be able to use the same tools to prototype on in-memory data, and then with very few changes, apply that to much larger data sets. So sort of thinking through that. I mean, the other thing generally, like it's sort of very, very hard to say like what the missing pieces are, and it continues to surprise me like how long it takes me to figure this stuff out. Like, you know, the principle of tidy data, which is basically put variables in columns, like that seems so obvious, but it took me like 5 years to realize like that was the underlying print. Like I could always like look at a data set and say, oh, I need to do this to it for it to be easy to work with. But to kind of articulate that principle in a way that I could communicate with other people takes a long time. So often like it just takes a long time for me to kind of notice like this is something that feels like it should be easier than it is. And so it's very, very difficult for me to predict in advance what the next thing is. Like similarly, like read Excel, the fact that people wanted to read Excel files into R, like it seems like a no-brainer, but for some reason it just never occurred to me, and then, you know, now it exists and thousands of people use it.
Anything else? So I'll throw you one last question. You're a tool maker, people ask you to apply your tools to lots of data sets. What's the either coolest, weirdest, craziest data set you've ever had to mess around with, and what do you find?
So I don't know, like ironically, I don't really do much data science anymore. But I will show you kind of the weirdest thing that you've probably ever seen in R. I don't think I'm going to show you anything like too revealing. But our house annoyingly has a shared water meter between like 5 other houses. And so I have like a CSV file that records the water bill and everyone's payments. And then I have this little script that like goes through, computes it, and then like creates an email and then automatically sends it, or creates a draft in my inbox. So like I apply R in like weird ways now because it's just like this tool that's very easy for me to use.
Does it adjust for like the number of people that live in the household or anything like that?
No, it's very primitive.